This video contains an E-Module for vulnerability assessment towards climate change, developed by Faculty of Geography, Universitas Gadjah, Mada. The main idea of these E-Modules are twofold. First is to give an introduction, basic concept, dimension, and methods towards climate change vulnerability. Second is to understand practical measurement toward climate change vulnerability. Why vulnerability become prominent within risk management? As we know, the risk formula involves hazard and vulnerability to come up with risk. It means vulnerability assessment is compulsory to address losses potential in certain hazard level. Let's start to understand what is vulnerability. Discussing vulnerability generally address people's disability to cope with certain level of hazard magnitude due to lack of protection. However, some scholars also argue that vulnerability also involves different subjects such as infrastructure unit and ecosystem. The basic concept of climate change vulnerability derived from this following IPCC schematic framework. As we know, our Earth has strong linkages with human system and vice versa. Within their linkages, there have been piled of evidence upon climate change driver due to human activities. Counterclockwise, we also have noticed that climate change processes impacted human system in many ways. Each system responds differently but synergize naturally. If human cannot cope with climate change processes and consider as vulnerable group, these may refer to either lack of protection or exposed to greater extent of impact. Derived from this schema, we may understand vulnerability as hidden impact due to particular hazard. The impact does not particularly address human system per se, since climate change also impacted natural setting and build-up setting. In other words, not only humans who are vulnerable due to climate change, we could also argue that natural and build-up environment also impaired by this potential hazard. This surely impacted vulnerability assessment, since each system described different response likelihood. Although some scholars would address it differently using diverse terms such as criticality or fragility. Hence, how to describe vulnerable situation? In practical level, there are various attributes to describe climate change vulnerability. This following slide presents that vulnerability assessment involves human system description, concern of cause, hazard potential, and temporal reference. An example, a vulnerability assessment of the tourism sector in a specified mountain region to climate change over the next 30 years. System refers to system analysis such as spatial setting, demographic characteristic, or social-economic background. Attribute of concern describes value of highlighted unit that is threatened by its exposure to hazard. For example, biodiversity, economic sector, ecosystem, and etc. Meanwhile, hazard system explores potentially damaging physical event, phenomenon, human activity that may cause the loss of life, property damage, and environmental degradation. Hazard may adversely affect a valued attribute of a system, and specifying temporal reference is particularly important to describe dynamic characteristic which subject to change. Given the different disciplines involved in the vulnerability study, there are many conceptual and methodological approaches to vulnerability analysis. Generally, it can be divided into two larger dimensions of vulnerability factors. First, sphere or scale and knowledge domain. Based on sphere or scale, vulnerability factors are divided into internal and external factors. Internal factors refers to properties of the vulnerability system or community itself, such as geographical condition, such as topography, and etc. Household, income, social network, land cover, and so on. External vulnerability factors refers to something outside the vulnerability system, such as national policy, disaster occurrence, such as earthquakes, storms, and etc., economic, policies, and so on. Based on knowledge domain, vulnerability factors are divided into socioeconomic and biophysical factors. Socioeconomic vulnerability factors are related to economic resources, social organization, and other characteristics of social group. Biophysical vulnerability factors are related to system properties investigated by physical sciences such as topography, environmental condition, land use, and other physical factors. Now, we will discuss vulnerability dimension and its measurement. If we take a look at the following VSD, or vulnerability scoping diagram, there are three important vulnerability parts, such as dimension, components, and measurements. First ring describes three fundamental dimensions of vulnerability that are exposure, sensitivity, and adaptive capacity. Dimension of vulnerability according to Fusel and Klein 2002 include this following. Exposure is the degree to which a system is exposed to significant climatic variations. Sensitivity is the degree to which a system is affected, either adversely or beneficially. Adaptive capacity is the capability of the system to adjust with climate change. Second ring describes the components of vulnerability or feature evaluated for three dimensions of vulnerability. Outer ring represent measurements or observable variable of the components of the dimensions. This is an example of vulnerability scoping diagram for drop hazard. Exposure component consists of exposed water supply, drop, and exposed population. Sensitivity component consists of water system, technology, demography, and supply response, while adaptive capacity components consist of access of technology, management structure, and access to information. Components of vulnerability have to be measurable. As we understand the basic concept of vulnerability, we need to get down with some data. The case study presented farmer vulnerability to climate change. Accordingly, we need several data, such as rainfall, temperature, disaster, human development index, and district profiles. These data need supported techniques using specified software as depicted within this slide. In addition, information spatial analysis often employed to generate vulnerability mapping. Some software are available for spatial analysis such as ArcGIS, Quantum GIS, and GRASS GIS. GRASS GIS and Quantum GIS are open source software. It can be downloaded for free. To add, spatial analysis generally combined with statistic analysis to come up with decision support system. The statistical analysis tool is needed to perform some calculation and classification regarding vulnerability components and parameters. To highlight spatial vulnerability, herein an example developed by Maplecroft. The spatial analysis for climate change vulnerability involves exposure mapping, sensitivity mapping, and adaptive capacity mapping. Proceed altogether using superimposed method from GIS software to generate vulnerability mapping. Maplecroft presented an example of climate change vulnerability for global scale. However, we could also work in detail to present micro-level analytical unit. As we work with spatial analysis, therefore, we work to quantify vulnerability. It means we conduct several processes such as weighting, scoring, also constructing index using principal components analysis. Principal component analysis functions as data reduction, summarize variables, construct test instruments, and index. We often work with several formulas depicted in the following slides and proceed several stages such as data reduction using factors analysis, extraction, and end up with generating scenarios. As we have completed this session, we will presume that vulnerability analysis for climate change is one among too many tools to predict future problems related to global issues. The review questions are: first, what are vulnerability dimensions and what example you could provide to describe vulnerability model?